This video is going to be on simplifying complex fractions. So what is a complex fraction? Well, a complex fraction is basically a fraction that has fractions in it. So if you got a fraction where there's at least one fraction in the numerator or denominator, then it's considered a complex. So it's not just one fraction, it's a fraction containing fractions. So, for example, let's look at 1/2 plus 2/3 over 3/4 plus 5/6. So this is a complex fraction because, like you can see, the numerator of my fraction has fractions, 1/2 and 2/3. And the denominator of my fraction also has fractions, 3/4 and 5/6. So that's what makes it complex. Now we're going to discuss how to simplify these. In this video, we're just going to consider one method. There's two main methods for simplifying these. We'll call this one method 1. And method 1 involves simplifying the numerator and the denominator separately, and then at the end remembering that the fact that a fraction simply refers to division. So we're going to treat the numerator as its own problem and the denominator as its own problem, but we're going to still do them simultaneously. So 1/2 plus 2/3, how do I do that problem? Well, in order to do that, we have to have a common denominator. And what is the LCD of 2 and 3? Well, that's going to be 6. So I need to multiply 1/2 by 3 over 3, and 2/3, the top and bottom, must be multiplied by 2. Now let's ask ourselves the same question down here. In order to add 3/4 plus 5/6, I also need a common denominator down here. And what's that LCD? It's going to be 12. So the 4 needs to be multiplied by 3, which means I got to multiply its numerator by 3, and the 6 by 2, meaning I had to multiply the 5 by 2. Now let's just write down what this is. This is going to give me 3/6 plus 4/6 over, this is 9/12 plus 10/12. Now these are really easy problems, so I look at them individually. Up in the numerator, I have 4 plus 3, which is 7, so 7/6 over, and now looking at the denominator all by itself, it looks like I have 19 over 12. Now this is where the important fact that a fraction is division becomes extremely helpful, because instead of looking at this as 7/6 over 19/12, let's think of this as 7/6 divided by 19/12. Because now I no longer have a complex fraction, and this problem becomes really simple. Because how do I divide fractions? Well, you flip the second and you multiply. So that gives me 7/6 times 12 over 19. And I see that 6 goes into 12 twice, giving me that the final answer is 7 times 2, which is 14 over 19. And I'm done. Now let's do one more example, one that has whole numbers and fractions in the numerator and denominator of my main fraction. So, for example, that doesn't make really any sense. 3 plus 5/6 over 1 plus 5/3. So I have to make the exact same approach here, except that when I'm adding these numbers, what's the first thing I do when it's a whole number plus a fraction? Well, I have to turn the whole number into a fraction. So I'm going to rewrite 3 as 3 over 1, and I'm going to rewrite 1 as 1 over 1. So that's going to be my first step. 3 over 1 plus 5/6 over 1 over 1 plus 5/3. Now that they're both fractions, I go through this same process up here. What's the LCD on the numerator? Well, it's 6, so I'm going to need to multiply my first fraction by 6. This one already has the LCD of 6, so I don't need to touch it. And this one, the LCD is going to be 3, so I multiply the numerator and denominator by 3. That gives me 3 times 6 is 18 over 6 plus 5 over 6 over 3 over 3 plus 5 over 3. And 18 plus 5 is 23 over 6 over 8 over 3. 23 over 6 over 8 over 3 is equivalent to saying 23 over 6 divided by 8/3. And in order to divide fractions, I have to flip the second and multiply, giving me 23 over 6. Let's actually, let's write this below instead. This is equal to 23 over 6 times 3 over 8, which allows me to cancel. So I'm going to say 3 goes into 6 twice. 23 is a prime number, so I know 8 doesn't go into it. And so I'm left with 23 times 1, which is 23 in the numerator, and 2 times 8, which is 16 in the denominator. And unless you are instructed otherwise, you can go ahead and give your answer as an improper fraction, 23 over 16. So there we go. That covers method 1 of simplifying complex fractions.